Hey guys, welcome to the last lesson of this unit. We're going to be doing U substitution with definite integrals. I'm not going to be teaching you any new type of U sub. All we are working with is definite integrals versus the indefinite, which we did for lessons 1 through 4. Okay, so pause the video and see if you can do the warm-up. So the warm-up here, what quantity squared gives me 49x squared? So I can rewrite it as 1 over 7x squared plus 1 dx, right? So I'm going to pick my u to be 7x. So du would be what? Just 7 dx. Now see what you have and what you want to replace with. I have 1 dx and I have that extra 7, so I'm going to divide by 7. So what am I left with? I'm left with just 1/7 du. So I'm going to pull that 1/7 out, and I'm going to rewrite this as du over 1 over, I'm going to switch the order, it'll be u squared. Now think backwards, or whose derivative is 1 over 1 plus u squared? It is indeed arctan of u plus c. Substitute back your u to what you picked it to be, arctan of 7x plus c, and that's your answer. Okay, again, part B is, if you look at the question, again, if you pick a wrong u and it didn't work, try another u or try a different method. Look at it differently. Maybe you didn't pay attention to the details. And I said, if you have something in the denominator, you always pick that to be u. Here, first of all, before I even do that, I need this to be 1. So how do I make this 1? I'm going to pull out the 49, right? You divide by 49, and that's how I make it to be 1. So I'm going to, this would be dx, and I'm going to pull out my 49. Right, my GCF is 49, so 1 minus, so this would be what? X squared over 49. So now, this is multiplication. Square root of 49 is 7, so can I not pull out my 1/7? I'm going to write it as 1 over 1 minus x squared over 49 square root dx. Now think about it. What quantity squared gives me x squared over 49? It is 1 over 1 minus x over 7 squared. Yes, so that would be my u. So I'm going to pick my u to be x over 7. So my du is going to be just the coefficient of x, which is 1/7 dx. I do have actually 1/7 dx. I can either choose to do that, or if I just want to pay attention to this 1 dx, I'm going to multiply by 7 on both sides, and I have dx as 7 du. Basically, my 7s will cancel out, right? And in my denominator, I would have 1 minus u squared square roots, and this would be du. These cancel out, and what are you left with? So whose derivative gives you 1 over square root of 1 minus u squared? It is arc sine of u plus c. So substitute back your u into it, which is what? X over 7 plus c, and that is your answer. Today, we are just going to do everything what we have done so far, but it will be bounded. So we won't write the plus c anymore, and that's what we're doing. So by changing the interval of integration to match the u substitution in the integrand, we can avoid the resubstitution step. So that would be another method. So I'm going to show you both the methods, and then I'm going to leave it up to you to decide which method you want to work with. Okay? So let's get started with example 1. So here you're given this integral and your bounds are given. Okay, few things that you need to keep in mind. These bounds are only for your x. So when you do your u substitution, you can't use these bounds. So what do you want to pick your u to be? Let's pick our u to be 4x cubed minus 1. So my du would be what? 12x squared dx, right? But look here, I have what? I have negative 12. I have this and this is what it is. I have negative 12x squared dx, and here I have 12x squared dx. Either I can choose to factor out, or I can just write -1, or just multiply by -1 on both sides, right? So I'm going to substitute the blue shaded part with negative du, and I'm going to set this integral up. So this would be u to the third du, right? And it'll be negative. I'm going to pull out that negative. Okay, I cannot use these bounds 0 and 1 here because these are my x bounds and this is u. So you're going to take the integral of this. This would be negative u to the fourth over 4, and I'm not going to write plus c. Once you substitute or replace the u back, that is when you write the bounds. So do not write the bounds before that. That would be wrong. So now when I do negative 4x cubed minus 1 to the fourth over 4. Now since it is x, so I'm going to take my bound. So that is something you have to remember. You can't just stop there. And no plus c because it's a definite integral. Now when you have your bounds, you do your upper bound minus your lower bound. So your upper bound is 1, so I'm going to just substitute negative 4 times 1 cubed minus 1 over 4. This is to the fourth power. And then negative, oh, the negative was not out here. So it was it was negative, and the 4 would be here. Okay. So this would be negative 4 1 times 0 cubed minus 1 to the fourth power over 4. If I simplify this, I get 1 cube is 1, 4 times 1 is 4, 4 minus 1 is 3, 3 to the fourth power is 81, and it will be negative 81 over 4. And here that would be 0 cube is 0, and 4 times 0 is 0. Negative 1 to the fourth power is positive 1/4, but you have two negatives here, so it'll become positive 1/4, which is negative 80 over 4, which is negative 20. So that's how you found it, right? So that was one method, one way of doing it. I just want to show it to you the other way. You already picked your u, which was what? 4x cubed minus 1, right? So, and again, the rest of the question is as it is. You took the derivative, I'm just copying it from there. But now I can find my u bounds. How do I find my u bounds? I can actually take my x bounds and substitute in here. So if I substitute, I get what? If I substitute 1, I get 4 times 1 cubed minus 1, which is 3, right? And if I substitute in 0, I get negative 1. So my u bounds, so when I do the integral, when I set this up, I can actually have these bounds from negative 1 to 3. I can put those bounds of u cubed du. You integrate it as you would. It would be negative u to the fourth over my u's and 4's. You have to be careful, right? It's negative 1 to 3. And now all you do is substitute in. So negative 3 to the fourth over 4 minus negative 1 to the fourth over 4. So negative 3 to the fourth is 81 over 4 plus 1/4, which is negative 80 over 4, which is negative 20. So no matter which way you do it, you do end up with the same thing. But two things to remember, that you cannot, I'm just going to highlight it, you cannot use your x bounds when you are writing u, right? You didn't use your x bounds here either. Only once you substitute, that's when you can use your x bounds. But here, when you found your x bounds, right, sorry, your u bounds by substituting in the x values in there, then you can use your x bounds when you're setting up the integrals. So I'm going to be working with the second method. It's totally up to you which way you want to do these questions. Okay, so let's try example 2. So here again, as per the guidelines, when you think about it, you pick something that's inside the parentheses. So inside the parentheses, I have u equals ln of x. So u is equal to ln of x. So my du is going to be 1 over x dx, which kind of helps me there because I do have that x in the denominator, right? So I have 1 over x dx and I get that replaced with. So I'm going to set this up. Remember, this is a u integral, so I can't use those bounds. So let's first set this up. So 1 over x dx is just du. And I have 1 plus ln of x is u squared, right? Now let's determine our u bounds. So I'm going to do it here. So if I do ln of e, which would be 1. So my upper bound is 1. And ln of 0, oh sorry, ln of 1 it is. ln of 1 is 0, which is 0. So my u bounds are 0 and 1, right? So if you look at it, or if I rewrite it, because some people like to see it, 1 over 1 plus u squared du. This part is what? This, or whose derivative gives me 1 over 1 plus u squared? It is indeed arctan. So we can write it as arctangent of u, and we're bounding it from 0 to 1. Okay, now all you do is substitute in, right? The upper bound minus the lower bound. So arctan of 1 minus arctan of 0. So basically, arctan of 1 is saying what angle for tangent gets us 1, which would be what? Pi fourths minus 0. So your answer is pi fourths. Okay, the next one, I want to do a few more with you before I leave you to finish the packet. So let's look at this question. Number 1. So here again, what would you pick your u to be? I'm going to pick my u to be 4 plus r squared, right? As per guidelines, pick something in the denominator inside the parentheses. So my du is going to be 2r dr. Now let's substitute and see what I have and what I want to replace with. I have 5r dr and I have 2r dr here. So I need 5r dr, or I can, right? So I'm going to multiply by 5 on both sides and divide by 2. So I'm going to divide by 2 and multiply by 5, right? So that would be 5 halves, right? I can pull that out, and then I'm not going to use those bounds because we have not yet determined that. That would be just du and 1 over u squared, right? Do we agree? Okay, so now what do I do? How do I determine my bounds? I'm going to substitute my -1 and 1 for r, and that would give me my bounds. So if I do 4 plus, I like to do the upper bound first, so 1 squared, which is just 5. And if I do 4 plus -1 squared, which also gives me 5, what happens when your bounds are the same? What happens when your bounds are the same? It is 0. You don't even have to evaluate the rest. You know the bounds are same. It is going to be equal to 0. So that's why I like the second method in comparison to the first one. Okay, now let's try number 2. Here again, what do you pick your u to be? Something in the denominator or something that is under the radical. So u is 4 plus 3 sine x. So du is going to be 3 cosine x dx, which kind of solves the purpose. I have cosine x dx in the numerator. I want to get rid of the 3, so I'm going to divide by 3, right? So I'm going to rewrite this as cosine x dx is just du, and I have square root of u. Now let's determine our bounds. So I'm going to do this here, 4 plus sine of 3 pi over 2. Again, you have to know your values, guys, exact values. So sine of 3 pi over 2 is -1. So 4 plus, oh, it's 3 sine -1. So 4 plus, let me rewrite this. So this is 4 plus 3 times -1 is -3. So this is what? Just 1. So my upper bound is 1. Then I'm going to do the same thing. I'm going to switch colors. So 4 plus 3 sine, It was what? 0. Sine of 0 is 0. So this is going to be 4. So now look here. Aren't your bounds in the wrong order? Why? Because your bigger number is at the bottom and the smaller is at top. And that can happen. So what would you do? You would switch them. And when you switch, you negate it also. So it'll be 1 to 4. Right? You negate the whole integral, not the bounds, the integral, and that's what you do. And can I not rewrite this square root of u as u to the negative 1/2 du? And now let's take the integral. The integral of that would be negative u to the 1/2 over 1/2, right? Oh, there was a 1/3. Forgot to write that 1/3. Yes. So this would be 1/3, right? And I'm bounding it from 1 to 4. So finish that. This would be dividing by half, the same thing as multiplying by 2. So this would be u to the 1/2 and bounded from 1 to 4. Okay, now what you do is just substitute in the upper bound minus the lower bound. So my upper bound is negative 2 over 3, 4 to the 1/2. And this would be negative 2 over 3, 1 to the 1/2. So 4 to the 1/2 is same thing as square root of 4, which is 2. 2 times negative 2 is negative 4/3. So this is negative 4/3 minus, this would be actually plus 2/3, which is negative 2/3. That's your answer. Okay. So this is how you do these questions, the definite integrals. So if you have any questions, guys, please feel free to reach out and finish up the remaining packet. Good luck.